So whatever the function given in the form of f of x, you write it in the form of a definition, then write its value, then solve the given limit. You will get the derivative of the given function. Now whatever the value inside the f, that is the x value, write it in the form of sin x. So if you apply the limit as x tends to 0, the h value becomes 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In our previous session, we have learned how to apply the limit for given functions, whether it may be a polynomial function or rational function or any trigonometric function. In this session, we'll be starting with the derivatives and the first principle of derivative, that is how to find the derivative of a given function. So first, let us look at the definition of the derivative. Now, suppose f is a real valued function and a is any point in the domain of the function. The derivative of f at a, at the point a, is defined as limit h tends to 0, f of a plus h minus f of a divided by h. So whatever the function is given, for example, suppose f of x is equal to x square is given. Then to find the derivative of this function at the point a, so we will write it as f dash of a. So here dash represents the derivative of a function at the given point a. Then this function must be written in the form of this definition, that is limit h tends to 0, f of a plus h minus f of a divided by h. So apply the value of the function here. So you will get f of a plus h as a plus h whole square minus a square divided by h, and apply the limit and solve the problem. So whatever the function given in the form of f of x, you write it in the form of a definition, then write its value, then solve the given limit. You will get the derivative of the given function. So this is the definition of the derivative of a function at the point a. So let us find the derivative by taking some examples using this definition now. Find the derivative of 99x at x is equal to 100. So first write the definition of the derivative, that is f dash of a is equal to limit h tends to 0, f of a plus h minus f of a divided by h. Now, given f of x is equal to 99x, at x is equal to 100 means your point is a is equal to 100. A is equal to 100. So, substitute here, it becomes limit h tends to 0. Here 100 plus h, f of 100 plus h minus f of 100 divided by h. Now if it is f of x, it is 99x. So in the place of x, you have 100 plus h here. Just replace it. Limit h tends to 0. F of 100 plus h is 99 into 100 plus h minus again here 99 into 100. So in the place of x, you are replacing with 100 plus h once, 100 once. So, and write the equation in this form, 99x form. Whatever the value is inside the f, write it in the form of 99x. So h. Now solve it, apply the limit. So 9900 plus 99h minus 9900 whole divided by h. This cancels. Now you are left with 99h by h. Again h cancel. Now you are left with only 99. So when you apply the limit for 99, which is a constant function, the value is constant. So the answer is 99. So this is the derivative of 99x at the point x is equal to 100. Let us take one more example. Find the derivative of f of x is equal to sin x at x is equal to 0. So let us write the definition again here. So f dash of a is 0 is equal to limit h tends to 0, f of a plus h becomes 0 plus h minus f of a is f of 0 divided by h. Now whatever the value inside the f, that is x value, write it in the form of sin x. So therefore it is limit h tends to 0. Now we have f of 0 plus h. f of x is sin x. f of 0 plus h is sin 0 plus h. Sin 0 plus h minus sin 0 whole divided by h. Now again here limit h tends to 0. This is sin h. Sin 0 is 0. We can live sin h by h. So this is one of the standard form which we have learnt in our previous session. That is limit x tends to 0 sin x by x form, whose value is equal to 1. So therefore the answer is 1. So therefore the derivative of the function sin x at the point x is equal to 0 is equal to 1. We'll take one more example. F of x is equal to 3x. Write the definition of the derivative at the point x is equal to 2. That is f dash of 2 is equal to limit h tends to 0, f of 2 plus h minus f of 2 divided by h. So a plus h we will take. A is 2. So I am replacing all the values of a in terms of 2. So therefore limit h tends to 0. Now f of x is 3x. f of 2 plus h is 3 into 2 plus h. And similarly here 3 into 2 divided by h. So limit h tends to 0. 6 plus 3h minus 6 divided by h. 6 minus 6 cancels. H cancels. You are left with only the constant value 3, and when you apply the limit, the answer is same, that is equal to 3. Therefore, the derivative of the function f of x is equal to 3x at the point x is equal to 2 is 3 only. So this is how we will find the derivative of a function at the given point. So if the point is not given, so in the definition of derivative, the value of a is replaced by h only, and that is called the general definition of the derivative. So here is the definition once again, which is called as the first principle of derivative. So in previous problems, we have found the derivative at a given point. So therefore, here the value of x is replaced with the point a. But this is the general definition to derive a derivative of a function, that is f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. The same method we will follow to find the derivative of a given function. Also to note that sometimes f dash of x can also be written as dy by dx. Why? Because any function can be written in this form. Y is equal to some f of x. We have studied in trigonometric chapter, relations and function chapter. So therefore, what we are doing here, we are deriving the function y with respect to x. So therefore, it is written in the form of dy by dx. So therefore, dy by dx is same as f dash of x. So anywhere you find this dy by dx or f dash of x, it means the function is derived there. So now let us start deriving using first principle, that is using the general definition of a first principle. So deriving using the first principle method carries 3 marks in your examination. Again, a very important topic for your examination purpose. So derive the given function using the first principle method. So for that, very first thing you have to do is you should write the definition of the first principle derivative. What is the definition? F dash of x is equal to limit h tends to 0, f of x plus h minus f of x whole divided by h. The same definition. So in the place of a, you are just replacing with a. Derive as it is, which the same step you have followed previously. Now, limit h tends to 0. Now, f of x plus h. If it is f of x, it is 10x. If it is f of x plus h, it is 10 into x plus h minus 10x whole divided by h. So, therefore, limit h tends to 0, 10x plus 10h minus 10x whole divided by h. Plus 10x minus 10x get cancels, h gets cancels. We are left with only constant value, and when you apply the limit, the value is 10. So, the derivative of f of x is equal to 10x is 10. In general, if f of x is equal to some constant into x, if f of x is equal to some constant, any constant into x, f dash of x or dy by dx, value is always the constant value. For example, if it is 3x, the answer is 3. If it is root 3x, the answer is root 3. So, any question of this form, the derivative is always equal to the constant value. Next question, we are taking one more function, f of x is equal to x square. So, apply the first principal derivative definition, that is f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h, which is the first principal derivative definition. Next, if f of x is equal to x square, then f of x plus h is x plus h whole square. Again here x square, same as in the definition, divided by h. Use a plus b whole square formula, a square plus 2ab plus b square minus x square you have, minus x square plus x square get cancels. You have h as a common factor here, take it out. So h get cancelled. Apply the limit as x tends to 0. So, if you apply the limit as x tends to 0, the h value becomes 0. So, when you apply this becomes 2x plus 0. Directly you can substitute value of h is equal to 0. It becomes 2x plus 0, which is 2x. So, therefore, whenever the functional value is x square, the value is 2x. We'll take one more example. Let us try f of x is equal to 1 by x. Apply the first derivative principle. F dash of x is equal to limit h tends to 0, f of x plus h minus f of x whole divided by h. So, it is limit h tends to 0, 1 by x plus h minus 1 by x whole divided by h. Now, limit h tends to 0, cross multiply x minus h divided by x into x plus h, and this h comes to the denominator. So, plus x minus x get cancels. Next, we are left with limit h tends to 0 minus h divided by x plus h into h. H get cancelled. Put h is equal to 0 there. 1 divided by x into x plus 0, which is x square. So, minus 1 by x square. So, this is the derivative of the function f of x is equal to 1 by x. So, in this way, using the definition of first principal derivative, we can find the derivative of any other trigonometric function. We'll take few more examples in the next session. Until then, keep watching, keep learning, and keep exploring. Thank you.